In the following video, I'm going to show how to find the missing angles of a right triangle using trigonometry. So let's look at the description here. The directions say to find the measure of each acute angle of a right triangle ABC with the measure of angle C equaling 90 degrees, and then round your answers to the nearest degree. So I have some right triangle of ABC, so this would be A and B and C, and the directions say that the measure of angle C is 90 degrees, so I'm going to indicate that here. The length of side A is 3, and side A is always opposite of our angle A, so that's going to be 3 here. C, length C, is going to be opposite angle C, that's going to be here. And then I'm going to try to figure out which trigonometric ratio to use to figure out what this angle is. So we have, by definition, sine of our angle is opposite over hypotenuse. Cosine of our angle is adjacent over hypotenuse. And tangent of our angle is going to be opposite over adjacent. So in this case, if I'm standing here from the perspective of this angle, then 3 is my opposite and 5 is my hypotenuse. So I'm going to use my sine function here. So I have sine of angle A equals opposite, which is going to be 3 over 5. And I'm going to find A then by doing the inverse of sine to get rid of sine. And the inverse of sine to both sides looks like this. These are inverses, they undo each other, and I'm left with A equals the inverse of sine of 3/5. And I'm going to just throw this into my calculator. And the inverse of sine of 3/5 gives me that I have 36.9 degrees. So A equals 36.9 degrees. Now if I want to find angle B, then I could, if I wanted to, from angle B from this perspective, then the 3 is my adjacent and the 5 is my hypotenuse. So I could, in this case, I could use cosine. I could use cosine of my angle B equals my adjacent, which is 3 over the hypotenuse of 5. And then we could do the inverse of cosine, so I have B equals the inverse of cosine of 3/5 to get the answer, to get what B is, which is going to be the inverse of cosine, the inverse of cosine of 3/5. And I'm getting 53.1. 53.1 degrees. Or another option, instead of using the inverse of cosine to find out what my other angle was, my other choice is I could have just taken, because of the triangle sum theorem, and the triangle sum theorem says that the sum of all the angles of a triangle add up to 180. So I could take 180, I could subtract the 90, and then I could also subtract the other angle that I found to get the same angle, the missing angle of 53.1. So either of these are going to be fine. I think for the next couple of problems, I'm going to use this method of just the triangle sum theorem, just subtract the other two angles to find the third one. All right, so let's look at the next one. I have some right triangle with angles A, B, and C, and I have length A, length C of 10. So I'm going to find, again, we have opposite over hypotenuse. We're going to use sine, so sine of angle A equals 5 over 10. Do the inverse of sine, so that I get A equals the inverse of sine of 5/10. Throw this into our calculator. So that I have the inverse of sine of 5/10, and that gives me 30 degrees. So A equals 30 degrees. So B must be, if C is 90 degrees, then B is going to be 180 degrees minus the 90 degrees minus the 30 degrees, and that's going to give me that B equals 60 degrees. Next one, I have some right triangle of A, B, C. C is 90 degrees. Length A is 9.1. Length C is 12.3. And so from the perspective of angle A, we still have opposite over hypotenuse. So I'm going to use my sine of my angle A equals 9.1 over 12.3. We're going to use the inverse of sine of 9.1 over 12.3. And that's going to give us so inverse of sine of 9.1 over 12, I think I said that wrong, 12.3, to get 47. So angle A is 47.7. And then I'm just going to subtract all of these from all my angles, 100, 180 minus this angle, and minus 90 gives me 42. So B, angle B must be 42.3 degrees. So there you go. Okay, so again we have a right triangle with, well, let's change this up. So I have A, B, and angle C. Length A is opposite of angle A, so that's going to give me 14.1. Length C is opposite angle C, which is going to be 18. And then let's find angle B first. So angle B, the 14.1 is my adjacent, and the 18 is my hypotenuse, so it looks to me like the choice I should be using is cosine. So I have cosine of my angle B equals 14.1 over 18. Do the inverse of cosine, so B equals the inverse of cosine of this 14.1 over 18. Throw that into our calculator. So I have the inverse of cosine of 14.1 over 18. And then we're going to take the 180 degrees and subtract 90 and the angle we just found, so that we have our two angles. So angle B is 38.4 and angle A is 51.6 degrees. We have another right triangle, A, B, C. Length A is 9.7, length B is 12.7, and length, well, I don't have a length C. So in this case, if I want to find angle A, I'm standing from this perspective over here, then my opposite, I have opposite of 9.7 and adjacent 12.7. So opposite and adjacent, which would mean that I should use cosine, tangent. Tangent, because tangent of my angle equals opposite over adjacent. So I'm going to use tangent. Tangent of my angle A is opposite over adjacent. Do the inverse of tangent, that gives me A equals the inverse of tangent of this 9.7 over 12.7, which then the inverse of, I did it again, inverse of tangent of 9.7 divided by 12.7 gives me that my angle is 37.4 degrees. Now, from the other perspective, we could just take the reciprocal. So I'd have 12.7 over 9.7 to give me my other angle. Or we could always take 180 degrees minus 90 minus our previous angle, and we're going to get that 52.6. So angle B is 52.6 degrees. Right, last one. So I have my right triangle, triangle A, B, and C. Length A is 14.6. Length C is 20.3. And from our perspective here, I have 14.6, which is opposite, and 20.3, which is my hypotenuse. So I'm going to use my sine function. So I have sine of angle A equals 14.6 over 20.3. We're going to do the inverse of sine, which is going to be A equals the inverse of sine of this 14.6 over 20.3. Throw this one into our calculator. The inverse of sine of 14.6 divided by 20.3 to get angle A equals 45.98 or 46. I'm just going to round to 46 degrees. We could, as I said before, we could use the cosine, the inverse of cosine of our the same proportions, 14.6 over 20.3, or we could have just taken it 180 degrees minus, or 90 degrees, minus that previous angle to get that 44 degrees. So our angle B is 44 degrees. So I hope this was helpful, and have a wonderful day.